Welcome to Math 106, Chapter 1.1, where we talk about slopes of lines. So at this point, we're able to graph a line of a function in the form of y equals mx plus b, so slope-intercept form. So it provides us the slope and the y-intercept. Or we also talked about this general form, ax plus by is equal to c, so through the x and y intercepts. And that was back in Chapter 0.2. So we have also, on top of that, learned about different orientations of your lines. So taking these three graphs, can you pause this video and determine the slopes of each line? Now, within this first one, we have two different lines. We have the red line and the green line. Your red line, right, if we typically have a line that's y equals, right? Well, this being a constant line, right? If it's a constant line, right, what is your slope? Well, we talked about this previously. If it's a horizontal line, you have a slope where m is equal to 0. So you have 0x plus b. Well, what is b? Well, b happens to be your y-intercept, which is 4. So really, this line in red is y is equal to 4. So if horizontal lines, right, have a slope of 0 because it's constant, therefore we have y is equal to 4. What is this green line? Well, this green line, right, has a slope that is undefined. And we'll talk about why it's undefined here momentarily when we talk about slope, right? So this one is undefined, and therefore, because it's a vertical line, we're going to, instead of using your y-intercept, we look at your x-intercept. This is where x is equal to 2. And notice that your x coordinate doesn't change, even though your y value does. And I'm just plotting these nice points, right? But notice that no matter where we are on this line, your x value doesn't change. Same thing with your y value. -3, 4, -2, 4, -1, 4. Your y value is not going to change, so it's constant. Now let's take a look at this other green line on this particular graph. So let's go ahead and determine the slope of each line, and maybe we take it a step further and put it actually into an equation. So your slope here, right, your slope, we just pick 2 points here, 2 nice points, and then we go in between your points. So we went down 2 and over 1, 2, 3. So because we had to go down, we now have a negative slope, and we're going to go down 2 and over 3. So now let's put it into the form y equals mx plus b. We have your slope. So y equals your slope, your m, x. And then what is your b? Your y-intercept is 2. Let's try it one more time. Again, finding your slope here. Your slope, we're going to pick 2 points. It can be any 2 points. Maybe you didn't want to pick those. Maybe you wanted to pick this one. You're going to go up 1, 2, and over 1. And because we are going upwards, we now have a positive slope. So your line here, if we were to create one, is 2x plus 3. So now in the graphs above, how did you determine your slope? So let's say you pause the video and you came back, right? How did you pick out your slope? Well, you picked out your slope from finding 2 points on your graph. For me, I picked these 2 over here, 1, 2, and again, 1, 2, 1, 2, 1, 2, right? And so you're picking 2 points, and when a graph is not supplied, we can use the formula for your slope. So given that we have 2 points, x1 and y1, and x2, y2, and let me just quickly label. Maybe I say this is x1, and this is y1, and this is x2, and this is y2, or you could reverse it. It doesn't matter. right? But you're just picking points that are nice on your graph if you can see your graph visually. And if not, these points are going to be provided for you. So now we get to look at the change happening in your y, right? Your change from point to point to get from this point A here to this point B here, we had to go up, right? Well, we went up of 2. So we're changing by 2. That change is coming from taking the difference between your y coordinates, y2 minus y1. We do the same thing, then we evaluate your x, the change in x. Again, how do we get from point A to point B? After you've gone 2, we then go left or right by how many? Well, we went over by 1. And that going over is, again, mathematically, we end up subtracting. We take the difference between your x coordinates. So your slope line, or your slope of your graph, has an equation of y2 minus y1 over x2 minus x1. Now, the slope of a line can also be referred to as the constant rate of change. Constant rate of change. Notice that this one is called the constant rate because we are not changing from point to point. Like your slope isn't changing no matter what point it is. So if you picked these 2 points versus these 2, or maybe you didn't see the one in the middle, as long as you have 2 points that you're evaluating between, right? 1, 2, 3, 4, 1, 2. So you have 4 divided by 2, that's still going to give you 2, which is the same slope. Notice that it's not going to change. So all of your slopes here are the exact same between your points. It's constant. Now, when we talk about when we have a slope of 0 and a slope of that is undefined, think about what we just learned about your formula. y2 minus y1 over x2 minus x1. So let's go ahead and say this is x1, y1, and maybe this is x2, y2, right? So when we take the difference, 4 minus 4 over -2 minus a -3, above we get 0, below we get 1. However, right, 0 over 1, that's just equal to 0. So your slope here is equal to 0, which we know is true. Now, if we did it again with your vertical line and chose 2 points, let's just say this is x1, this is y1, x2 and y2. So we get -2 minus a -1 over 2 minus 2. These are your y coordinates. These are your x coordinates. So notice that up top, double negative turns to positive. We get -1 over 0. Now, is a 0 allowed in the denominator? No, it's going to cause an issue, so therefore it's undefined. So that's why these two slopes are slightly different. It just depends on the type of line that you have. So now let's take a look at finding an equation of a line passing through those 2 points. So as you saw me do previously, just kind of walking you through why this is the case here with a 0 slope and you're undefined, can you do the same with these 2 points? So if we know that your slope is equal to y2 minus y1 over x2 minus x1, and we have these here, x1, y1, x2, y2. I like to label everything. It doesn't matter which one you label. If you wanted the first point to come and be x2, y2, that's fine. Just don't swap your x's and y. Don't trade your points. So let's go ahead and work it in. I've labeled -3 as y2 minus a -2. This minus sign comes from your equation. This negative sign comes from my point over 2 minus 1. So let's go ahead and put that into your equation. or let's go ahead and evaluate. So double negative, we get -1 over 1. Therefore, m is equal to -1. Now, when it comes to your slope of a line, and I wish I didn't write so big. So step 1 is find the slope. So if slope isn't given, we need to find your slope based on your 2 points. Step 2 is use your equation that you know right now. So I haven't shown you another equation. So the only equation that we have is find b using y equals mx plus b. Or actually even a step before that. Maybe that's our next one. Step 2 is pick a point. So between your 2 points, which one do you like better? Let's take this one. So let's choose the point 1, -2. Now step 3, find b by using your point. So I'm gonna go back one more. This is your x coordinate here. This is your y coordinate here, which corresponds to these x's and y's here. You already have your slope, which you just found as -1. So let's go ahead and put those in. We have -2 is equal to -1 times 1 plus b. So we get -2 is equal to -1 plus b. Add the 1 to the other side. So you're now at -1 is equal to b. So when I go to put it into your equation, right, last step, number 4, put into the equation, we can do y equals your slope, -x minus b. Because this is your b here, this is your slope here, and we're just putting it right into the equation. Let's have you try it again with example 2. See if you can pause the video and attempt it yourself. So it says find an equation of a line that goes through these 2 points. So again, I'm going to label here x1, y1, x2, y2. And my slope is y2 minus y1 over x2 minus x1. So we have 7 minus 2 divided by -4 minus 4. So we get 5 over -8. So that's my slope here. Let me actually pick a different color to write that in. There we go. So step 2, let's go ahead and pick a point. I want the point, let's say 4, 2. It doesn't matter. 4, 2, m is equal to 8, or -5 over 8. And we're trying to work it into y equals mx plus b. I'm going to shift some things around. There we go. So we know that this is your y, or your slope. Your x is this point here, and your y is that point right here. So let's go ahead and work that in. 2 is equal to -5 over 8 times 4 plus b. Now we talked about fractions, or maybe this is the first time we're seeing a fraction, right? But let's go ahead and take a look as to multiply, because we can multiply your tops and your bottoms. One way to do that with your fractions, right, is if you wanted to, you can certainly multiply and make this -20 and divide by 8 and start to simplify, right? They both have a 4 in it, and then they'll pair down. You can do that initially as well. Notice that 8 has a 2 times a 4. So we can go ahead and cancel out both of these 4s. So your leftover is -5 on top, because we've canceled out this 4. This 8 we rewrote as 2 times 4, which again, this 4 got canceled out with the 1 above. So your leftover is 2 is equal to -5 over 2 plus b. Now let's go ahead and keep solving for b. We can add 5 over 2 to the other side. So now b is equal to 2 plus 5 over 2. Now, when it comes to adding those fractions, we need a common denominator. Unlike when we multiply, we can multiply just straight across, top to top, bottom to bottom. Adding and subtracting, we need the extra step of finding a common denominator, which in our case is going to be 2 from the one below. If they're different, you can always multiply by either side of the your denominators. So we get 4 plus 5 all over 2. Common denominator, we're just going to keep as 2. 2 times 2 gives us 4 plus the 5, which is equal to 9 over 2. So this is what your B is. So now you have your B is 9 over 2. You have M as negative 5 over 8. You have Y equals MX plus B. So let's go ahead and work all those in. Y is equal to negative 5 over 8X plus B, your 9 over 2. Notice that I'm not replacing my X and my Y anymore because it's a line, right? And this one is actually a downward sloping line because it's negative. We're going to have lots and lots of points that we're hitting. Notice that it's only 2 points that are listed that we can hit, but we can go ahead and find all sorts of points on your line, given that we have 2 variables that we can just plug in. Now, this is just one method. If we're trying to find your equation of a line, there's another useful one. This is called point slope form. So the one we are working with, y equals mxb, is slope intercept form. This one is called point slope form because it gives us a point and our slope. Can you identify those for me? Well, here is your slope. M is still M. And we got a lot of X's and Y's in place. We have this point here, Y1 and X1. This is going to be your point. This is your X coordinate of the point. And this is your Y coordinate of the point. So therefore we have your point X1, Y1. Now, if we're trying to form the equation of a line, we only can work in one point. Just like we did here, we had to pick one of your 2 points. Same rule applies over here. Pick one of the 2 points. If you picked 2 points, right, then that just means that you don't have your slope. You need to solve for slope, which you then divide this over here, and you're back to an equation for your slope. So let's say we decided we didn't like this approach and wanted to do it differently, right? After we have found your slope, which we had for this one as -1, and we have the equation y minus y1 equals x minus x1. X minus x1. Let's go ahead and pick that same point, 1 comma -2. So with here, right, we can go ahead and replace those points, this being y1 here, this being x1. We'll do the same exact thing. Y minus y1 is now -2 is equal to m times x minus your x1, which we said was now a positive 1. Now notice that with your equation, the double negatives still matter. This one, right, we had a negative, even though it's positive, right, that one's going to remain unaffected. So now we have y plus 2, because double negative makes positive, is equal to -x minus 1. Now we can't leave it in this form. We need to get it back into the form y equals mx plus b. That is just for me. That's what I'll be asking you on your test. So what's the first thing that logically you would want to do here? Well, it's up for debate. You could subtract the 2 over, or you could distribute. It doesn't matter at this point. Let's go ahead and distribute. Y plus 2 is equal to -x plus 1. Notice that you're going to multiply throughout the whole expression. Then we can go ahead and subtract your 2 to the other side. So we're at y is equal to negative x minus 1. And you'll notice that no matter which path you take, it's still going to be the exact same. Now let's have you try it one more time. You're just using that alternate method. That way you can kind of get a feel for both of those. All right, so let's try it again on this one. See if you can pause the video. We have that. I'm going to choose the same exact point. Your point doesn't matter. We have y minus y1, x minus x1. This is your x value. This is your y value. There you go. Let's go ahead and work that in. Y minus y2 is equal to, and I wrote a little bit too big for this particular one. Let's go ahead and put it right underneath. Y minus 2 is equal to negative 5 over 8 x minus 4. Let's go ahead and distribute first. Negative 5 over 8 plus, because that double negative. And now let's say I didn't know that this part could reduce like that. And instead, I just multiplied straight across. So 5 times 4 is 20 over 8. What I would want to do here before continuing, and I left off my x here, before I continue to bring over my 2, let's go ahead and reduce. What do 20 and 8 have in common, right? Well, the biggest value that they have in common would be a 4. So we can write them both in 4. If you said, okay, well, maybe a 2, then you could write 10 and 2 and 2 and 4, and then cancel out your 2 and then have to do it over. Typically, you want to get the biggest value that they have in common to make it a little bit simpler for you. Cancel out those 4s. You're left with 5 over 2. Now let's go ahead and add that 2 to the other side. Plus 2, and then we can make it into a fraction real quick. Same rule applies. We'll get 4 over 2, so we can add 5 plus 4, and you'll again get that same response. Y is equal to negative 5 over 8x plus 9 over 2. Now to break it down, if I were to kind of make a step-by-step process, right? We want to convert into y equals mx plus b formula. So the first thing you do once you put everything in is to distribute. So number 1, distribute m through. So distribute your slope. Step 2, add or subtract y1 to the other side. And step 3, we combine like terms. And I'm just going to rewrite this direction real quick. Convert y minus y1 equals to mx minus x1 into slope-intercept form. There we go. All right, so that should be it on how to create an equation of a line. I hope you found that informative.